In the part 1 of this SQS video, we discussed about the SQS intro and the usage, SQO benefits, SQS message workflow, and the queues available in SQS and the cost optimization of the SQS. So now in this video, we will discuss how to create the SQS from the AWS console and how to implement the SQS client from Java code. Now we will see how to create a queue from the AWS console. For that, first we have to log in into the AWS console. So I am already logged in. So then we can search in the search bar using the SQS keyword, and then we will see the list and click on this simple queue service. So we will see this page, and here we can see that there are already existed queues. So this page will basically showing all the queue existed queues. Now for creating a new queue, so just click on this create queue. Now we can see there are two type of queues. One is standard, second is FIFO. So standard is basically like we already discussed, standard where delivery order is not same as we send to the queue, and FIFO where delivery order is first in first out. So first let's go with the standard queue only, and the name of queue is the let's post demo v2. Now this part is the configuration of the queue. So first is the visibility timeout. So visibility timeout means, as we discussed in part 1, like the time when the message is consumed. After that, the time basically for which this message is not available to all the consumer. Means if we are specifying 30 seconds after consuming once that message will not be available to all the consumer for 30 seconds. Next is the message retention period. That means storing the message in a queue. So queue is basically storing the message from 1 minute to basically 14 days. So queue can store this unprocessed message till 14 days. So let's go with only the default one for day. Next is the delivery delay. That means if we wanted to send or if we wanted to add a delay for the consumption. That means if we are sending a message to the queue, so that message will not be visible for some time. So let's suppose if we are specifying 10 minutes, so that means after sending the message to the queue for 10 minutes, this message is not available to or is not visible to all the consumer. So let's go with zero delay only. So next is the maximum message size. So 256 means the 256 KB. For this demo, 256 KB is sufficient. Now the next is the receive message wait time. So that means short polling or long polling. So that means like for consumer, so if there is no message, so how much time consumer will wait, or how much for how much time consumer open the connection. I am specifying here 20, so I'm using long polling here. The next part is the encryption. So as we discussed, okay, this encryption is for the message body encryption. We already discussed like we can use also SQS keys, and we can also use Amazon KMS keys, or we can also use our custom keys. So for now I'm disabling the encryption. Now the next is the access policy. So access policy means like who can send or who can consume the messages. So currently by default the only the key owner can send or key owner can receive. So for that, if we are clicking on this, we have to specify the ARN. So for this ARN is basically the SQS user. We have to create the SQS user. So how to create the SQS user? So go to the IAM console. So here click on the users. So now click on the add users. Now here specify the username. Let's suppose the username is demo v2. So then click on next. So here we have to specify the permission. Click on this attach policy directly and then specify the permission. If you search with the SQS, you can see there are three type of permission: full access, read only, or the SQS queue execution role. So I'm giving the full access because I want this user manage the full SQS. Click on the next, then the create user. So this user is created demo v2. So click in this user. So now here we can specify the set permission boundary. So permission boundary it is SQS full access. So here permission boundary is set now. Now we need to create the secret. So we need to create the access key or the secret key. For setting up the queue, we need only ARN. So this is the ARN. I'm copying the ARN here. So here I'm pasting the ARN here, and I am also pasting the queue owner. So who can send the message? A queue owner or this user. So same thing I am setting here. So now only this user or the queue owner can send or receive the messages. Now the next is the retrieve allow policy. That means if we wanted to use this queue as a dead letter queue, who can send messages to this dead letter queue? So if we enable this, that means to allow all, means allow the all the queues to use this queue as a dead letter, or by a queue name. We can also specify the queue name, or if we don't want to use this queue as a dead letter queue, deny all. So let's go with the disabled option. The next is the dead letter queue. If we wanted to set the dead letter queue for this queue, we can set. Here we have to specify the queue name, which queue we can use as a dead letter queue, and then set the maximum receive count. So that is basically means this queue will try or will attempt send 10 times to the consumer. After 10 times, the still message is in the queue, then this message is available for the DL queue. Now I am disabling this option. Next is the tag. So tag is basically just it's a just optional. So this tag we can use for the cost. If I wanted to see like how much this queue is costing to me, then I can specify my tag. So this tag is just a key value. So I'm specifying the tag. So here I already created a tag, this test scope or testing. So now click on this create queue. Now we can see the queue is created. So here we can see this is the queue URL, and here we can see the monitoring part. We can monitor the queue, how many messages are basically sent or received to the queue. So if we wanted to add it, we can add it. We can change whatever we configured now. We can change like configuration and all that. Now how to use this queue in our code. So I have created this project. So here we will see how we can implement the newly created queue. So for this project, I'm using Java as a language, and the framework is the Spring Boot, and the editor is the IntelliJ IDEA. What kind of actions we will cover in this video? So one is send message, receive message, or delete message. Now, how many clients we are covering here? Two type of clients. So simple client or the buffered client. What are the ways to send the messages? One is the single message, second is the batch messages. Now let's see what is the project structure. So I've created these classes. So first is the AWS key. So where I have mentioned this key, secret or the access key. Second is the health control. This health control is just to check the service health. It's just a ping pong endpoint. The next is the message controller. So message controller is basically where I mentioned all the APIs. So I have created all the APIs like if I wanted to send the message to the normal client using the standard queue. So this is the endpoint. If we wanted to send the batch messages in the normal client and standard queue, we can use this endpoint. Same for the FIFO here and the same for the buffered client here. And then there are two type of services I'm implemented here. One is the SQS service, second is SQS buffered service. So SQS service is basically using the normal SQS client. SQS buffered service is using the buffered client. So here we can see like I have implemented all the methods: single message, send batch messages, FIFO single message or FIFO batch message. Same for the buffered. And now how to receive. So this is a receiver service. So here I have implemented receive message. One is using the simple SQS client, and second is basically using the buffered SQS client. The next is the SQS config. So this class is basically I'm using for the configuration, like to specify which reason we created the queue, what is the queue name, what is the endpoint, what is the dead letter endpoint. And here I'm initiating the client. So first is the simple client and second is the buffered client, and we can ignore this is for the dead letter. So this is simple client, this is the buffered client. So let's start with the simple client. In the simple client, so first we have to create the AWS client builder. So that is taking two parameter, one is the endpoint and second is the reason. Endpoint means the queue endpoint, so that we can get from here. This is a queue endpoint, so let me set here. That is I am already using this one endpoint. Second is basically the credential. So for that, create this class AWS static credential provider, and that basically pass this basic AWS credential that is taking two parameter. One is the access key, second is the secret key. And then we can build the Amazon SQS client with these two parameter. And for the debugging part, I'm just getting the queue and just printing the queue URL. So this is the simple client. Now how we can use this client to send the message? Go to the message controller. First start with the simple, that is a single message. So here to send a single message we have to create the send message request object. So here we need to pass the queue URL, that is the endpoint, and then we have to pass the message body. And then using the SQS client, we can call the send message and pass the send message request as a parameter. That's it. With this code, we can send the message to the SQS. So let's see. Let me run this. To run this, you can click on this. We are getting the URL. That means our client is configured and client is able to connect with the SQS. Now let me call that endpoint. This is the endpoint, like localhost normal client standard single and textd 0101. That is a message. So basically, if I am going here, so we can see this is the endpoint normal client standard single message. So if I am clicking on this, I'm getting the response. And if I'm going here, so we can see there is one message. To send the batch messages, what I'm using here, in the same class in the SQL service, there is a method send batch messages. For that, we have to create the send message batch request object. So here, this is a basically batch. This is like a bucket where we have to pass the entry, all the message entries. Here I am creating the list of entries. Then I am passing this entry to this batch request. And then I am sending the batch request and calling this method send message batch and passing the endpoint and the entry list. So with this basically, so we can send the 10 messages in a one API call. Here what I am doing, I am creating the send message batch request entry. If we are using batch, then the message ID is mandatory. So I am passing the message ID here. So just I am creating a random message ID. Now that's it. We can send batch messages with this code. Let me send the batch messages. So this is the endpoint where we can send the standard batch text study. So we are getting the response. And if we are going to console, so here we can see I'm getting the success response. So here in the batch, what I am doing, so batch is also sending some response. So here result is a response where we can check like is there any failure in the message. If there is a failure, we have to retry. And if there is success, that we can check what all message are basically successfully sent. Let me refresh. Here we can see I am seeing this window. Let me extend the window. So here we can see I'm seeing this 10 messages on the number of messages sent. Now let's see the receival and deletion part. So for receival and the deletion part, we have to go to this receive service. In the receive service, so here I have created the method receive message. Now receiving is like a polling. So for continue polling, I have created this runnable instance, and here I am passing the runnable to this thread and then starting the thread. Now what I'm doing here, so here I am creating the receive message request class and passing the queue endpoint and passing how many numbers, maximum number of messages I wanted to receive as a one API call, and how many times I'm basically waiting. So I am specifying here the 20 second because we are using simple client. So here I'm using SQS config dot receive. You can call this receive method to get the all the messages. Now here I'm checking this messages list is empty or not. Then I'm printing the messages. And after printing the message or consuming the message, I am using the same client to deleting the message. For deletion, I am calling this method delete message and passing the endpoint and passing the receipt handle. So receipt handle is basically I'm getting in the message object itself. It is unique for in every message. If we passing this, then we are receiving. If we see in the run, I'm getting this message. So message received one, message is deleted, next message is received. Now if we can see here, for one API I'm getting one message. With this basically AWS will cost charge me for every API. If I am receiving one message in the each API call, then AWS will charge me 10 times. Now how to reduce this cost? So for that, we can use the SQS buffered client. Let's see how to initiate the SQS buffered client. Go to the SQS config class. In the SQS config class, this is the init buffered client. So here in the init method, I am initiating the init buffered client. Here we can see we can create this Amazon SQS async. So Amazon SQS async is a class, and here we need to pass the credential. After passing the credential, we need to configure the queue buffer configuration. That is the main part. So here are some properties. So first property is the max batch open millisecond. That means if we are sending or deleting the message, if we are passing in one by one messages, so then this queue buffer will basically initiate the buffer and wait for till 200 millisecond. And then if we are sending, let's suppose 4 or 5 messages, AWS this buffer client will club all the 4 or 5 messages in one batch and send that one batch in one API call. No need to create additional buffer, or there is no additional setting is required. We can set this time, like if I am setting this, let's suppose a 1 minute or 1 second, means for 1 second I'm waiting and letting AWS buffer client to convert individual messages into the batches. So that will also help us to reduce the cost or reduce the API calls. Second is the with max in flight outbound messages. That means like how many threads we wanted to use for sending or deleting. So this is just a concurrency. So we can set for the throughput point of view. If we are using high number of threads, basically we will achieve high number of throughput. We can send multiple, or we can delete multiple messages in one shot. Now the next is the with max batch size. Like these three configurations are for the receiving purpose. So how many messages do we wanted to receive in one batch? That is batch size. And this is basically the with max in flight receive batches. So that means like how many threads we wanted to use to receive or to pull the batches from the SQS. And the next is the max done receive batches. That means like how many messages we wanted to prefetch means if we are requesting 10 messages, so in one API we will fetch 100 messages, and then we will receive or we will consume 10 by 10. Now if we are specifying the 100, now for 100 means 10 into 10, each batch having a 10 messages. So that means these threads basically we will use, or SQS will use to pull the messages. If I am specifying the 20 threads, means each thread can consume one batch. So that will help us basically to consume more messages. So with this properties, we can also reduce the cost and we can also get maximum throughput. And here I'm also setting the long polling bills. I'm waiting, receiver is waiting for the 20 millisecond, and if there is no messages. The fun part is basically to consume this buffered SQS is very simple. Just replace the SQS with the buffered SQS. So let me go to this SQS buffered service. We can see here in the send single message, everything is same. Only I just replace the SQS with the buffered SQS. Same for the batch. So here everything is same. Here only I'm replacing with the SQS with the buffered SQS. So this is the best part of the buffered client, that is basically backward compatible with the simple client. Now the only part is basically at the receiver end. On receiver end is also simple. So in the receiver, so here we can see receiving the buffered messages. So this buffer client also offering the asynchronous nature. So let's see how. So here in this case I am creating the receive message request class, passing the queue URL, and then I am calling the buffered SQS dot receive method, and here passing the request body. Now here I am getting the messages. If I am getting the messages, I am also using the delete message batch request to deleting the message. Here I am getting the messages. I am creating the entry and creating a list with the list, and then passing the list to this delete message batch request object. Set entry and then setting the queue URL. Now we can also use the sync method, and we can also use the async method. So here for delete message, I am using the async. So here we can see we can call this delete message batch async method, that will basically delete the messages in another thread. Now we will see how this configuration will help us to reduce the cost. I'm showing one simple demo. So here what I'm doing, I'm just stopping this receiver polling here. So we will call the endpoint to fetch the messages. So what I'm doing, I'm just restarting the service here. So here what I'm doing, I am sending multiple messages in one API. In one batch I'm sending 10 messages. Let's send 50 messages. 10, 20, 30, 40, 50. So here we can see I have basically sent 50 messages, and this metric is showing number of messages sent is showing 50 messages. Now at this time you can see at 1919 there is no receiving. So let me receive these messages. Why I'm showing this? Because I have set this configuration means we are prefetching 100 messages. And if I am calling this endpoint receive buffered client, this will call only once. Means we will only calling the once that API. In that API, we will fetch all the messages, 50 messages, but we request only 10. Due to this prefetch configuration, this client basically stored the extra 40 messages in the local storage, and then we can consume from the local storage. So with this, basically we can reduce the API calls. So let me call this. So now we can see in one API call, consumer is consuming 90 messages. So 50 we sent, and 40 are basically the old message that is present in the queue. So 90 messages in the queue, but we consume only 10 messages. So here, how many messages I consume? Only 10 messages, 4 or 8. So in one batch, this SQS client only send the 8 messages. So if I am calling again this endpoint, this is not hitting the API again. So here we are getting 10 messages. If I am calling again, so we can see how quickly we are getting the response because these messages are coming from the local buffer. So I have uploaded this project on the GitHub. If you are interested, you can check out this GitHub link. So in this video, I have covered whatever we discussed in the part one. So in this video, we have seen the implementation of SQS, how to create SQS from the AWS console, and how to implement the SQS in the code, and how we can config the SQS in the code for the cost optimization techniques. Thanks for watching this video.